As in this question, there is given that three blocks ABC are suspended with the help of three pulley and two threads with equal horizontal separation between the adjacent blocks. So this separation initially is same for all of two, and initially the block are held at the rest at the same level. So initially they are in the straight line and then released. The block move in such a way that they always remain in a straight line. Okay, if an instant the block B is observed moving downward with a velocity of 4 meter per second relative to the A, right? So then what is the velocity of this ABC we need to find out. Okay, so this is a question from the Pathfinder. Let us solve this. So what we are going to do is let us initially consider it like this. This is the block E, this is block B, and this is the block C, right? They are at the equal separation from each other like this, and then initially they are horizontal in a straight line like this. Okay, all right. And now when they will move, they are moving in such a way that like this, always they are in a straight line like this, right? I'm rotating this straight line, so like this they are rotating. It means, of course, the B is also going down, but with respect to the B, A and C are moving in such a way that they remain in a straight line like this. So what I will do is, I will solve with respect to B. Look, if I take B as a frame of reference for this question, if the velocity of the A with respect to B is something, the same velocity will be there for the C with respect to B, but in opposite direction. Velocity of the C with respect to B will also be same, right? Okay. Now what do we know is this, that the velocity of the B with respect to A is given as 4 meter per second in the downward direction. Then velocity of the A with respect to B will be 4 meter per second in the upward direction, no doubt in that, right? Okay, now let us suppose like this, that the A is moving up, B is moving down, okay, and C is also moving down. Now look at this pulley. This pulley, if the A is moving with VA, then the pulley will also move with the VA in the downward direction, right? Okay, so then one thing I can say from the constraint is that the VA, which is the velocity of pulley, is equals to VB plus VC divided by 2. All are positive, so that's why I can say 2 times of VA is equals to VB plus VC. Another thing I know here, look, VCB and VAB magnitude is same, right? So I can say VCB is VC minus VB, right? That is 4 meter per second in the downward direction. So VC basically becomes 4 plus VB. There is no doubt in that. So here I can write down this equation. This equation can be written down as 2VA is equals to VB plus 4 plus VB. What about VA? Look here, the VAB is 4 meter in upward direction, so VAB can be written down as VA, and look here, VA is upward, VB is downward. Let's take upward positive, then VA minus of VB is basically VAB, right? And VAB is given as 4 meter in per second in upward direction, so I can say that the VA plus VB is basically 4 meter per second. So VA becomes 4 minus VB. Okay, if I put this value over here, then I will get 2 times of 4 minus VB is equals to VB plus 4 plus VB. So that we are getting here 8 minus 2 VB is equals to 2 VB plus 4. So basically 8 minus 4 is equals to 4 VB. So 4 VB becomes 4. So VB becomes 1 meter per second, and we have chosen the direction. If you remember here, We have taken that the VB is downward, so that's why VB is downward. What about VA? So VA is 4 minus VB, so VA becomes 4 minus 1. So VA becomes 3 meter per second, and what is the direction? Upward direction. And what about VC? So VC is somewhere here. Yeah. So VC here we are getting it as 4 plus 1. So that becomes 5 meter per second in the downward direction. These are the values. I think hope you have understood this question. Thank you.